In the previous lecture, we saw what is modulation and the importance of modulation. In this lecture, we will understand what are the different types of modulation process available in the analog communication system. Modulation is defined as the process by which some characteristics such as amplitude, phase, and frequency of a carrier signal is varied in accordance with an information varying signal or message signal. Modulation process contains message signal or modulating signal, carrier signal, and modulated signal. Modulation in the analog communication. We have seen that in the analog communication system, transmitted signal is an analog signal, and the modulation techniques which are used for the transmission of the analog signal from sender to receiver is known as analog modulation. And in the digital communication, transmitted signal is a digital signal. The modulation techniques which are used for the transmission of the digital signal is known as digital modulation. Now let us see different types of modulation available in the analog communication system. Modulation is mainly of two types: continuous wave modulation and pulse wave modulation. Continuous wave modulation can be divided into amplitude modulation and angle modulation. This angle modulation can be divided into frequency modulation and phase modulation. Again, pulse wave modulation can be divided into analog pulse wave modulation and digital pulse wave modulation. Analog pulse wave modulation can be further divided into pulse amplitude modulation or PAM, pulse width or duration modulation or PWM, pulse position modulation or PPM. Digital pulse wave modulation can be divided into data modulation and pulse code modulation. In this lecture, we will talk about analog modulation. So modulation used in the analog communication system are mainly of two types: continuous wave modulation and pulse wave modulation. Let us understand what is continuous wave modulation. In the modulation process, there are basically three signals involved in the modulation process: message signal, carrier signal, and modulated signal. If the carrier signal is a continuous signal like a sinusoidal signal, then the modulation is known as continuous wave modulation. So in the continuous wave modulation, the carrier signal is a high frequency sinusoidal signal, and the characteristics of this high frequency sinusoidal signal will be varied according to the message signal or modulating signal. Pulse wave modulation. If the carrier signal is a periodic sequence of rectangular pulse, then the modulation is known as pulse wave modulation. In the pulse wave modulation, the carrier signal is a sequence of rectangular pulse, and the characteristics of this rectangular pulse signal will be varied according to the message signal. Now, continuous wave modulation is divided into two types: amplitude modulation and angle modulation. In the continuous wave modulation, we have said that carrier signal is a high frequency sinusoidal signal, and it has characteristics like amplitude, frequency, and phase. According to the definition of the modulation, these characteristics of the carrier signal will be varied in accordance to the message signal or modulating signal. So what is the amplitude modulation? In the amplitude modulation, the amplitude of the high frequency carrier signal is varied in accordance with the instantaneous value of the modulating signal. Let us understand what is amplitude modulation graphically. Here, this is a message signal. This is a high frequency carrier signal. Here, the amplitude of the high frequency carrier signal will be varied with respect to the message signal. As we can see, the amplitude of the modulated signal increases with the increase in the amplitude of the message signal, and the amplitude of the modulated signal decreases with the decrease in the amplitude of the message signal. And when the amplitude of the message signal is maximum, then the amplitude of the modulated signal is also maximum, and when the amplitude of the message signal is minimum, then the amplitude of the modulated signal is minimum. How to obtain the expression of the modulated signal and the different properties of the modulated signal like maximum and minimum amplitude will be discussed in details in the lecture of amplitude modulation. Here we just saw a brief introduction to the amplitude modulation. Now, what is angle modulation? In the angle modulation, angle of the high frequency carrier signal is varied in accordance with the instantaneous value of the modulating signal. It can be categorized into two types: frequency modulation and phase modulation. In the frequency modulation, the frequency of the high frequency carrier wave is varied in accordance with the instantaneous value of the modulating signal. Let us observe this modulation graphically. Again, this is a message signal and this is the high frequency carrier signal. As we can see, the frequency of the high frequency carrier signal is varied with respect to the message signal. the frequency of the modulated signal increases with the increase in the amplitude of the message signal, and the frequency of the modulated signal decreases with the decrease in the amplitude of the message signal. The amplitude of the modulated signal remains constant and it is equal to the amplitude of the carrier signal, and when the amplitude of the message signal is maximum, the frequency of the modulated signal is also maximum, and when the amplitude of the message signal is minimum, then the frequency of the modulated signal is also minimum. Phase modulation. In this modulation, the phase of the high frequency carrier signal is varied in accordance with the instantaneous value of the modulating signal. Let us see this modulation graphically. Again, this is a message signal and this is a high frequency carrier signal. As we can see, the high frequency carrier signal is varied with respect to the message signal. In the phase modulation, amplitude and the frequency of the carrier signal remains constant. There can be infinite number of points in the phase of the modulated signal where the phase shift in the signal can take place. The phase of the carrier signal gets changed according to the instantaneous amplitude of the modulating signal. When the amplitude of the modulating signal is positive, the phase changes in one direction. If the amplitude of the modulating signal is negative, the phase changes in the opposite direction. Pulse wave modulation. If the carrier signal is a periodic sequence of rectangular pulses, then the modulation is known as pulse wave modulation. Pulse wave modulation is of two types: analog pulse wave modulation and digital pulse wave modulation. In the analog pulse wave modulation, the amplitude, duration, or the position of the rectangular pulse is varied in accordance with the instantaneous value of the baseband modulating signal. It can be categorized into three types: pulse amplitude modulation or PAM, pulse width or duration modulation or PWM, pulse position modulation or PPM. Pulse amplitude modulation. In the pulse amplitude modulation, the amplitude of the rectangular pulse carrier wave is varied in accordance with the instantaneous value of the modulating signal. It can be divided into two types: flat top pulse amplitude modulation and natural pulse amplitude modulation. In the flat top pulse amplitude modulation, the amplitude of each pulse is directly proportional to the modulating signal amplitude at the time of the pulse occurrence, and the amplitude of the signal cannot be changed with respect to the analog signal to be sampled. The tops of the modulated signal remains flat. In the natural pulse amplitude modulation, the amplitude of each pulse is directly proportional to the modulating signal amplitude at the time of the pulse occurrence, then follows the amplitude of the pulse for the rest of the half cycle. The tops of the amplitude of the modulated signal is directly proportional to the amplitude of the modulating signal. Let us see this modulation graphically. This is a message signal and this is a train of rectangular pulses used as high frequency carrier signal. Here, the amplitude of the train of the carrier pulses is varied with respect to the amplitude of the message signal. The amplitude of the modulated signal decreases with the decrease in the amplitude of the message signal, and the amplitude of the modulated signal increases with the increase in the amplitude of the message signal. When the amplitude of the message signal is maximum, then the amplitude of the carrier signal is also maximum, and vice versa. In the flat top pulse amplitude modulation, the tops of the amplitude of the modulated signal remains flat, but in the natural pulse amplitude modulation, the amplitude of the pulse is directly proportional to the amplitude of the modulating signal. Pulse width or duration modulation. If the width or the duration of the rectangular pulse carrier wave is varied in accordance with the instantaneous value of the modulating signal, then the modulation is known as pulse width or duration modulation. There are three variations of the PWM, and they are leading edge of the pulse being constant and the trailing edge varies according to the message signal or modulating signal. Trailing edge of the pulse being constant and the leading edge varies according to the message signal. The center of the pulse being constant and the leading edge and the trailing edge varies according to the message signal. The width of the duration of the modulated signal starts to decrease when the amplitude of the message signal is increasing, and vice versa. Now let us see the first case of the pulse width modulation. This is a message signal and this is a train of rectangular pulses used as a high frequency carrier signal. Here, the duration of the train of carrier pulses is varied according to the message signal. The width of the pulses is varied in this method, but the amplitude of the signal remains constant. Here, the leading edge of the pulse remains constant, but the trailing edge is varied according to the message signal. Here, The trailing edge of the pulse remains constant, but the leading edge is varied according to the message signal. Here, the center of the pulse is constant, but the leading edge and the trailing edge are varied according to the message signal. Pulse position modulation. If the position of the rectangular pulse carrier signal is varied in accordance with the instantaneous value of the modulating signal, then it is known as pulse position modulation. Now, let us see this pulse position modulation graphically. This is the message signal, and again this is a train of rectangular pulses used as a high frequency carrier signal. The position of the pulse varies in this method, but the width and amplitude of the signal remains constant. Pulse position modulation is done in accordance with the pulse width modulated signal. Each trailing edge of the pulse width modulated signal becomes the starting point for the pulses in the pulse position modulated signal. Hence, the position of these pulses is proportional to the width of the pulse width modulated pulses. Digital pulse wave modulation is divided into delta modulation and pulse code modulation. Digital pulse modulation is based on sampling and quantization techniques, which will be discussed in details in the incoming lectures. Without understanding sampling and quantization techniques, we cannot understand delta modulation and pulse code modulation. So we will understand delta modulation and pulse code modulation after understanding sampling and the quantization techniques. That's all for this lecture. If you have any doubts regarding this lecture, then you may ask it in the comment section, and don't forget to hit the subscribe button. See you in the next one.